Welcome back. A very quick break. Now let's move on to our next lecture today, which is conceptual modeling. So, what is modeling? So, what is your understanding of model? What about like Google Online? And let's have a look at what is model. Let's have a look at images. Models. This is not the model we are looking for. Okay, so here's a model, right? This is a model of a car. Have a look at other models. This is a model of climate, a concept diagram of climate modeling. So this is a model of climate. What else? Oh, yeah, these are also models, but not them. This is also a model, like a model of a building. I think okay, so here's a business model. A company's plan for making a profit. So this is a model of business. This is an interesting one. What else? So this is a model of, I don't know, what is it? So these are all models. What else? So what is model? So what is your understanding of models? Like a business model, it's a company's plan for making profit, like the process, the plan, and we also need to evaluate it, and there are also different types of business model. So model is a simplified representation to assist in understanding something more complex. For example, a model of a building, right? Well, there are different ways that you can discuss the plan of a building with your group. Like we want to have 3 floors. We want to have double brick. We want to have it in red color. We want to have a kitchen, like 2 bathrooms. Like we can use the words, like natural language, to describe like a general plan. But sometimes it can be a little bit hard to understand. So this is also why, like when you have like a models for that building, you can have a diagram or visual tool to help that process. And this covers everything from mathematics through model like aeroplanes, the same. Like before you build an aeroplane, you want to make sure everything is planned ahead with good understanding of the things. So you want to have like a model. So now move further on conceptual modeling. Again, let's have a look conceptual model. Okay, so this become more abstract. So conceptual model, have a look. What is conceptual model? Conceptual model. So we have different blocks and they may have some relationships. Here we have input, environment, and then outcome. So kind of like a process and different state of a system. Other conceptual models, like the conceptual model of the water quality. And yeah, so this is conceptual model in general. So it's a type of model that captures a system in a conceptual way rather than in a physical way. So we are not building like a physical model of a building or a physical model of an aeroplane, but we are building this system in a conceptual way. So this is called conceptual model, and it tends to be more visual. So we may have like mathematical models, like data models. So data model is this is another, so data model. Let's find an example of data model. Data conceptual models. Oh, what is that? So we have providers, show, category, episode. So different data in a system. We model the data in a system with a conceptual model, with conceptual modeling. And here in software, conceptual model normally can fall into one of the two types. One is called structural, and the other one is called behavioral. So structural modeling emphasizes the state structure of the system. Remembering what is the state of the software, like the current state of the software, like the current value of the properties, current value of the variables. So this is the state of your software, like a snapshot of your software at the current state. And we can conceptualize this structural modeling using like UML class diagram, which is commonly used in object-oriented programming, and also others like for database we can have ER diagrams. So ER diagrams is covered in a course like 3311, a database course. So you will learn about ER diagrams. Another way of conceptual modeling in software engineering is behavioral, meaning that we are not emphasize the status structure of the system, but we want to put more emphasis in the dynamic behavior. Like a system can move from one state to another state triggered by an event. So we can modeling this dynamic behavior using behavioral models, including state diagrams and use case diagram. So we will focus on state diagrams today, and after we come back from Flexi Week, you will also learn about how to use case diagrams. So why do we need these models? Why these models are important in software engineering? First one, maybe they are important for predict future state of affairs. So for example, this current page, this current slide is showing this slide having what are the models used for. And then with the conceptual modeling, you may know when we click on that button, if we move on to the next slide. So before we click on that button, before we trigger that event, we know from the conceptual modeling if we click on that, another slide, the next slide will be shown to us. And we can also understand the current state of affairs, with the models. And we can also determine the past state of the affairs. When we have a model modeling the different state of your software, and the workflow of your software, what will happen, what has been happened before this slide. And also can convey the fundamental principles and basic functionality of the system. So you do not need to read each line of your code, but with a conceptual model, you can communicate your software to another people, maybe in your group, maybe not in your group. So you can introduce what your software does with a conceptual model, but you do not need to read each line of your code to that person. So it's easy for communication. So this is more theoretical. Okay, so now this is what we are going to focus today, one type of conceptual modeling in software engineering, which is state diagrams. So state diagram is one type of behavioral modeling, meaning that we want to capture the dynamic structure of our software. Okay, so this state diagram captures different state and how we can transit from one state to the other state. Okay. Yep. So here's the example of for example, we have a store. Okay. This store now, the state of this store is closed. And if we push this handle, push it, now the state of this door is changed to open. Right? So the different state of this door. So we can capture this state using the circles. So the circles represent the state, like whether it's closed and whether it's opened. And we also have those arrows, like this arrow here on the top and another arrow down here. So these are the transitions. And we also have open and close here. So these are the events that trigger the transition from one state to another state. So there are three key components of a state diagram, which are states, closed, opened, and also transitions, the arrows, and also event. So three components of a state diagram. So state diagrams are used to describe state machines. What is state machine? So state machines are made of a finite number of states, and software is one example of state machines. Like there are other examples of state machines, like your car is a state machine, like your computer is a state machine, like have infinite number of states. Right? And software is one example of state machines. And state diagrams can be used to describe state machine, not only software. So state diagrams can not only be used to describe software, but can also be used to describe other state machines. Okay, and the machine, like here the software, can be transitioned from one state to another through an action, like the event. So other examples like UI with different screens. So this is the current screen, like the current state of our screen. And if we trigger an event by clicking on this button, so this is the event, and we will move to transit to another state of this screen. Okay. Okay, so let's have practice. Sorry, 1 second. So let's do a practice together. Let's draw a state diagram for like a parking meter. So when you want to park a car, like in a park, like car park, you need to pay for it. So the way we do it, so let me connect my iPad. Yeah, we received the feedback earlier that you like me to use iPad more for drawing. So I try to do my best to incorporate your feedback. So your feedback in through the QR code is valued. Okay, so now let's have a look. Let's draw together for parking meter state diagram. So when you draw a state diagram, we need to start with some states. So what are the states for a parking meter? So first of all, when you go to the parking meter first, so remember, like we capture the state using circles. So this is our first state. They may ask you to enter your plate number, right? Your car's plate number. So the first step will be enter plate number. And then you may enter number. So this is the event, which is enter number. Well, after you enter the number, it may ask you like how long you want to park, right? So your parking, like the parking meter will transit to the next state. And in this next state, they will ask you to enter like duration, like whether you want to park for 1 hour or 2 hours, right? So your parking meter now transits to another state. And then another event happens, like you enter duration. Okay, this parking meter will transit to another state, which is ask you to insert coins. Ask for like you enter the plate number, you tell them how long you want to park, and now your parking meter will ask you to insert coins. Okay, so what's next? You have told the parking meter your number plate, how long you want to park, and they are now ask you to insert coins. What is your next event to trigger it to transit to another state? Give it money, right? Insert money. So you may insert $1, $2, like insert money. And then they may tell you confirmed. So now you can park now, right? So it's almost done. So the next state, oops, oh, no, what is that? So the next state is confirmed. Okay, so now, can you see clearly? Yep, okay, good. Sorry about my handwriting. So now you want to design this parking machine, and you bring this conceptual model to your team members, and you want to have a discussion on your design. So if you are my team member, are you going to give me any feedback on my conceptual modeling? Am I capturing all the states, like all the potential states of this parking meter? Is there anything that I missed? I forgot to consider. Do you think it's good? Anything I have missed? We are a team now, like we are designing a parking meter. Yep. Sorry? Insufficient money? Do you want to draw directly? Like. Did you mean people left before confirm? Or maybe you can just edit more on my drawing. Do you want to make some edits? I can give that to you. Change their mind and decide not to move forward, right? So that's a good point. Anyone wants to make some edits to my model? Anything that I've missed? Anything that I should consider? I was thinking maybe like when I insert coins, for example, it asks for $3. And the first event that I triggered is putting $1. And then another event, like putting another $2. So actually I can trigger this insert money event a couple of times before it can be confirmed. Right? So for example, you put in $1 and the parking meter will tell you we need more, right? So maybe we need something like a loop for this insert coins. And in this loop, the events may happen a couple of times, which is insert money, right? Okay, so when the money is money, it can trigger the next state, which is confirmed. And also we can cancel at any time, like go back at any point. So now we have like sufficient money event. Maybe there's also like another event called insufficient money. And you enter a couple of times, but you found that you only bring $1 today. Like you do not have $3 to park here. So you may go back, like cancel it from here, and also eject the $1 that you have already put in the cart, like the parking meter. Yeah. Okay. Anything else? Yeah, so you can see that with conceptual model, it's easy to understand and easy to for communication and make change to your plan before you implement the details. Right. Cool. So let's go back. Oh, another thing that we might not have considered is when you put in money, or when you, like for example, you enter your plate number, here you enter your plate number, you enter duration, and then you just left. So will that parking meter stay at the state called enter duration? Or will it go back to the initial state, like waiting for the next people come to the parking meter, right? So maybe we need another one at some point here, like 5 minutes passed, and the user did not proceed. Like they did not trigger the next one. So that will come back to the initial state. And also here, we may also have another event, like 5 minutes passed. Right. So this is our model here. So you can find it also in the slide. Okay, so another activity. Can we also model the login system as a state machine? So it can be similar. So let's do that together. I will share my screen again. So you will see like conceptual modeling in future iterations. And also in the individual project, in addition to like just programming, editing the roles, you may also see some like conceptual questions, like a short report. Okay. So now let's have a look at login system. So what is the initial state of a login system? What can be an initial state of a login system? Maybe ask for your username and your password, right? It asks you to enter username and password. Okay, and then a user enter their put in their username and the password, and it will trigger another event. What this event could be? Confirmed. Quite straightforward. Like they put in the correct username and the correct password, and then they just logged in successfully. So this is correct. So the username match with the password. And if it's incorrect, we will trigger another state, incorrect. Correct. And another shape here, another circle here. Oopsie. And this login platform will say incorrect. It will tell you that it's incorrect and ask you to enter your username and password again. Okay. my handwriting. I'm so ashamed of that. Okay, cool. So this is how we model our software systems using state diagrams. So there are like a recap of state diagrams. So there are 3 components, like the states, the arrows which represents the transitions, and also the events which trigger that transition. Another useful tool for drawing conceptual models. So I just drew it on my iPad, like using pen and the paper. But you can also use some tools to draw conceptual model, which is called Lucy chart. So Lucy chart is very powerful in drawing conceptual models. So here are some that I draw before using Lucy charts. For example, what is this one? Like I think I used that last. Okay, so you can transit from state A to state B, to C, D, and you can also have the event here. You can write down the event here. What is that? And also the transitions using these arrows. So this is using Lucy chart to draw the diagram. And you can also collaborate on drawing these conceptual models by using Lucy chart. So you can have different people working on a same project using Lucy chart. Yep, that's it. Cool, great. So this lecture is quite straightforward and not very complex. Any questions about either conceptual modeling or the maintainability lecture? All good? All good? Cool, great. So that's all for today. I hope you can enjoy your Flexi week. I will see you online in week 7, and we'll come back in person in week 9. I'll see you again. Cool, great. Thank you so much. Oh, remember that we have a lot of help sessions in this course, and sometimes our help session is empty for a while. So you can hop into the help session and have some one-on-one help on your labs, on your project, and you can also have some random chats. And TEM also offer pizza delivering and pet services, joking, like in the help session. But we do have a lot of help sessions. Check the schedule and get some help. Thank you, everyone. Feedback, feedback, feedback.